All right, good morning, everyone. Thanks for being here on a rainy and cloudy and cold morning. So today the plan is to talk about some descriptive statistics and how we use them to calculate various attribute fields and how they're best applied to mapping approaches. We will also do a tutorial on how we actually work with data and visualize distributions of data in ArcGIS Online. So I will be posting a link in Teams if you want to follow along in ArcGIS Online. So that'll go up there in the lecture content channel. And then I had a question earlier about the format of the exam. Just like the take-home reading quizzes, I'm going to put it on D2L. You're going to have a time limit, will be the only major difference. It'll be longer than the reading quizzes. So you'll have the freedom of completing the midterm exam anytime. I think it'll be like 8 a.m. or 6 a.m. to midnight. Yeah, so that'll be the format. It'll be a D2L exam. You want to make sure you're using a stable internet connection just to avoid any issues like that. But I think we should all be used to using these quizzes now because we've done several reading quizzes so far in the class. So any questions on that? If I'm remembering correctly, the exam is scheduled for next Thursday, right? Next Thursday. I will post some. I've got a practice quiz, which I'll put up that you can help use to study. So look for that being posted on D2L as well. All right. Oh, and another thing was, I think this was one of the weeks where lab was a bit more challenging to complete during the lab time. And that occasionally happens throughout the semester. The lab this week, cartographic design, I'll just tell you is a little bit shorter. I'd expect you will be able to complete it during lab time. But Mary did post for her lab sections, she has office hours on Wednesday from 3:15 to 4:15, gains 140. So if you want to drop in and get some more hands-on help from Mary, you could do that. And actually, if you're in Hayden's class, feel free to join as well, just because she will be there answering questions. All right, so let's talk about descriptive statistics. Everyone's favorite thing to do at 8:30 in the morning. But I think the stats are really fun for interpreting how you should symbolize your data. And also, it really makes your mapping approach more effective to be able to work with simple derived statistics. So, one example of why understanding the statistics of a data set is important is just the data set size. As we get more and more data, for instance, the census data, right? We have a ton of information to work with. It's really important to understand distributions of the data, be able to visualize outliers, exclude those. And this is the building block for doing classification. I mentioned this last time. Classification is when we bin our data to help with symbolization, right? Let's say you want to use 5 colors instead of an infinite number of colors to represent data. You've got to decide where those class breaks are to set the sizes of your bins. And the stats are the determining feature or the determining factor in that situation. So 2010 census had 64,000 plus variables for 73,000 census tracts. And that's not even the most detailed group that you can display in the census data. You can actually get down to a finer detail with block groups. So if you just consider the data set size for the 2010 census, that was 4.7 billion. Obviously, larger data sets going to be more important to understand the distributions in the data. So I expect you to understand these 4 simple derived indices. I also want you to know how to calculate them. One of the nice things about online exams is I can do simple things like, hey, click on this Google Sheets link and type in a formula. So there might be a practice question that walks you through that step. But, calculating the ratios between 2 different attribute fields, proportions, percent change, and the rate. And I'll show you some examples of how we use these derived indices to make maps. So the ratio is simply the number of one thing to a number of another thing. And for all these simple equations, F just represents the frequency. You can think of that as the count if you're observing some variable, right? This could be the ratio of dairy cows to horses, something random like that. Could be the ratio of people with a college degree to the total number of people. One interesting example map looks a lot better on your screen. This is actually from a few years ago. It'd be interesting to see an update of this with the recent spike in home prices and cost of living increases in the nation. But this is from adventuresinmapping.com, and they used a simple derived index, which is let me ask you, what is the derived index that you think is being mapped on this map based on reading the map and the title here? Yeah, it is a little confusing. It definitely relates to the median home value. We are mapping what looks to be counties. So counties would be our enumeration unit in this case, right? It's a Choropleth map. And the ratio in this case is specified right there, right? Ratio of median home value to median income. And when you say it in those terms, it doesn't make too much sense. But if you think about it more broadly, this is like if you saved 100% of your median income in a county, or just the typical person's income, saved 100% of it, how many years would you have to do that to pay for a house in cash? So there are, believe it or not, a few places in the country where the median income can buy you a home, at least a few years ago. West Texas is one of those places. 2 years of income is a huge swath of land in the Midwest. Also corresponds to places where they like to drink beer, if you remember that map from last lecture. Really good autocorrelation there. 3 years of income, 3 years of the median income. Actually probably gets you a house in eastern Montana, although this might have been elevated to maybe 4, etc. So this is just an example of how a simple ratio between two things can sort of illuminate interesting trends that you can map using a Choropleth map visualization technique. Any questions on that? So proportion. This is the number of items in one group divided by the number of all items. So who can come up with an example of a proportion for me? Someone from this side of the room. How about we make the large N total population? So what are we going to make F sub A there? Anyone? We can just sit here all day. On this side, anyone got an example? Yeah. Awesome. Probably about 43% based on my mental math. I recognize it's an early class. Yeah, that's a good example. Or like the percent of the population that owns a home. Or maybe the number of single family homes as a proportion of total housing structures in a county, something like that. I like it. Here's an example of a map that uses some interesting symbolization strategies to show global carbon emissions. This is actually a few years old now, but this is from 2015. And what it does is it takes each individual country's carbon emissions and divides them by the world total, which is shown down here in the bottom. 36,262 megatons of CO2 globally. Source here is globalcarbonatlas.org. And in 2015, and I think still today, if I am correct in my memory here, China has the largest proportion of the global total CO2 emissions. But as we can see, based on the size of these symbols here, the US is not too far behind. And China is much more populous than the US. So on a per capita basis, right, the story might change a little bit. Your choice of which index to use really does affect how the map is visualized. Right, we might change this to per capita CO2 emissions, and in that case, the US is the global leader. Right, we consume more energy than any other nation on Earth, so our symbol would be much larger. All right, so just to review, numerator in that case would be total CO2 emissions. F sub A would be emissions by country. We could have a table and we calculate this derived index for each individual country and then map that. Percent, I'm sure you've calculated this before. Pretty intuitive. The only tricky part is just to multiply things by 100. So notice it's actually the same equation as our proportion. But we just multiply it by 100 to get a number that is somewhere between 0 and 100. With 100% being all of it, right? So we might expect in this case, China's global CO2 emissions would be something like, I don't know, 15% of the global total. Actually, we could go ahead and calculate that, right? It's 10,357 divided by 36,262. So it's actually closer to 1/3. Multiply that by 100 to give you about 33%. Here's an example from a few years ago during the COVID pandemic. A lot of people were very concerned with what percentage of the population was vaccinated, right? So either fully vaccinated or had a booster or had one shot, et cetera. And we can map this with a Choropleth visualization. So how we would do this is just take the total population of Montana on the denominator. Numerator would be the number of people who were vaccinated, and then multiply it by 100. That would give you some number on a scale of 0 to 100. We can see our scale for this map down here. Darkest blue was 70%. So at this time, it looked like the Northeast and the West Coast had about 70% vaccination rates, and then Montana and the Deep South had much lower vaccination rates. Actually, I mixed up my terminology there, right? I said vaccination rate. I want to be careful about that because this is a percent, right? A percent could represent a rate, but there's actually a more precise definition of rate I want you to know as well. We can also calculate percent change, right? So if we have, let's say we had 20%. So let's just simplify Montana and say 1 million people. 20% of that would be 200,000 people were vaccinated. Let's say a couple months go by and we go to 300,000 people. In that case, we could calculate percent change. So I just said, let's add some notes here. New value is 300K. Old value is 200K. Old value, 200K. K just representing 1,000 here. Get rid of that, 200K. So we'd end up with 100,000 divided by 200,000. That's 1/2, right? Or 0.5. Multiply by 0.5 by 100. You're going to get 50% change. So yeah, why multiply by 100? Obviously, we're converting it to a percent. If we didn't multiply it by 100, we wouldn't have to use that percent sign. It would just be 0.5. A lot of people would understand what that means, obviously, but for most map readers, I think percent is more intuitive. So 2020 census data came out. You might remember that there was a lot of difficulty getting census responses at this time, right? During the pandemic, it was a hard time for people to go around knocking on people's doors. So the data were a little bit more interesting than in previous census iterations. However, they have been released and finalized. And once this data was released, we were able to do things like calculate percent change in population. Notice here, Gallatin County is one of the places where that dark blue color scheme is being used to fill in that county enumeration unit, indicating that we were one of the counties in the nation that had the highest population growth. Some general trends, like people move to the Intermountain West. A lot of people move to the Pacific Northwest. A lot of people moving to the Sun Belt states, especially into urban areas, Texas, Florida, etc. A lot of people leaving rural areas. That was one of the trends in Montana. You know, we have counties like Missoula and Gallatin County containing Bozeman gaining a lot of population, but at the same time, small towns, rural areas actually losing population in this 10-year period. All right, so I mentioned there is a precise definition for rate. This is the number of occurrences out of all possible occurrences, adjusted to be a value out of some number of people. So the practical use case for this derived index is when you have a very, very small number, right? Think back to the COVID pandemic. Actually, the fatalities, luckily, although tragic and there was a very large total number of fatalities, the rate in terms of the total population was still quite low. So this would have been a very good metric to use to actually communicate like how many people were infected or how many people ended up dying from this disease. So we can imagine like number of possible occurrences in Montana being 1 million. Let's say there's a few hundred people who are affected in some way. You can multiply that by 1,000, and that'll give you a rate out of 1,000 people. You can multiply it by 10,000 and get a rate out of 10,000 people. So depending on how small your number is, you might want to choose different numbers to multiply it by to represent your rate with like a simple number that's easy to understand. You know, for example, case fatality rate was a big metric during the pandemic. Obviously saw a big spike early on in the data, and then luckily it tailed off as medical treatments improved and vaccines came out, etc. This could also have some interesting effects from the way the data was counted, right? It's hard to get really good data from all the countries in the world. So there are some, you know, aspects of the statistics that we have to probe further to fully understand them. But these are small numbers, right? You can actually represent them with percent, or you could multiply them by 1,000 and get a number out of 1,000. Let's say one person out of every 1,000 was affected in some way. Divide 1 by 1,000, it's a very small number. It's like 0.0001. Multiply that by 1,000, you get 1, right? It's easier to communicate. All right, so I want you to think about what type of derived index is population density. And then I want you to actually write out the formula for that in your notes. How do we calculate population density? All right, we're gonna have a fraction, right? So what's on top? Population, yep. Thank you. And then when I say density, right, it's implying how much population is concentrated in an area. So the area is going to be on the bottom. Population over area. So the units at the top would, of course, be like number of people. Units on the bottom could be square miles, could be square kilometers. Those are the typical ones you see, right? Depending on specialized applications, you could choose a different area unit. Doesn't really matter as long as you communicate which unit you are using. Have you had to calculate any metrics in lab yet? I don't think you have, right? Nope. So one of the things I will show you how to do is actually run these calculations. It's very similar to an Excel spreadsheet, but it's not quite as intuitive, unfortunately. And so we'll get some practice. Actually, I want to break here for a second. So if you got your computer, I want to show you a few tricks of the trade here. First off, if you've got a spreadsheet program like Excel, you can load that up. I am just going to start a blank Google Sheet. And I realize probably a lot of you have written formulas in Excel, but if you have not, it's a really good time to start. It's very, very useful. So I just want to show you how to calculate some simple derived indices in Excel. Google Sheets would be very similar, right? So let's pretend we have a population column. And we're going to have an area column. And then let's say we have cases of disease. Something like that. Let's say we have cases in, let's do something more exciting. College grads, 2010. And college grads, 2020. So let's pretend, let's insert a column here to the left, and let's say, you know, Gallatin County. Is the county that contains Missoula, is that called Missoula County? Yeah. So obviously Gallatin County is superior to Missoula County in every way. We're going to have a higher percentage of college grads, of course. All right, we're just making up numbers, but they've got 1,000 less people, so we're better. Let's make this, right, square miles. I honestly don't know the area of Gallatin County off the top of my head, so let's look it up. 2,632. Whoa. And let's look up Missoula County. Pretty similar, 2,618. While I'm at it, let's just go for population. $119,500. $122,700. So we are a little bit more populous. Just filling in some random numbers here. They had one college graduate increase. 10 years. So if we wanted to calculate population density, right, we just walked through that. But on a spreadsheet program, if you want to run a calculation, you just hit equals. That will enable you to write formulas, right? Population. So you could either type in that cell coordinate, which is the column and then the row number, or you can click on it, equals B2 divided by the area. So that means for every square mile in the county, there's about 46 people in Gallatin County and 45 in Missoula County. So population density, let's do the percentage of college grads. So in this case, we want the number of college grads divided by the total population. And we might want to put parentheses around that fraction, although I think it would work out either way, but just for illustration purposes here, right, we're doing that division, and then we're multiplying by 100 to convert this to a percent. 10%, probably not an accurate number, but you know, on the same order of magnitude. And then of course we, have a higher college graduation percentage, 10% versus 8%. Let's calculate the grads rate per 1,000 people. How would we do that? We would need to know, that would be the college grads divided by total population. And then if we wanted to know how many college grads there were out of 1,000 people, we could multiply that by 1,000. So that means for every 1,000 people in the county, we've got 101 college graduates. Finally, just a final example here, let's do percent change. So remember, it's the, let's just review this. New value minus the old value over the old value times 100. So let's see the change in college grads between 2020 and 2010. We're going to say equals. In parentheses, we want to subtract the new value, sorry, the old value from the new value. So 12,500 minus 10,000, close parentheses, divided by the old value, right? We're measuring how much change since 2010. We put the old value on the bottom, and then we're going to just multiply that by 100. And it means we get 25% change, right? That makes sense. We've had an increase of 2,500. With respect to 10,000, it's 25%. Not sure what just happened there. Let me redo that calculation again. Oh, that's right. It is a very small number because it is actually a very small number. And just one trick in Excel, if you want to just take your formula and move it down one row and also change the position of the cells that you're calculating, you can just hover over it until that box appears in the bottom right and drag it down. So this is how we do it in Excel or any spreadsheet program. Any questions on that? All right, but how do we actually do this in ArcGIS Online? If you're following along, fire up Teams and click on that link I sent out. it would be in lecture content. And this is just a feature layer from Esri, managed by Esri Demographics Division. You can see it was created in August 2021, updated in November of that year. And we can read about some of the fields that are available, what types of calculations have already been done for us, etc. But we might want to do our own calculations. So if that's the case, Esri is not going to let us modify the underlying data of their layer. But what we can do is export the data. And in this case, I want you to choose a shapefile. Give it a name, and you can tell it where to save in your folder, because that shapefile will be exported to your ArcGIS Online account. Note that not all layers on Living Atlas will have this capability, right? Some layers you can actually turn off the permissions. So you don't want people downloading your data and converting it to different formats. You can do that, but this one is available for your use. So once it's been exported, you'll see that the format has changed, showing up here that it's a shapefile now. It is now owned by me, which means I have the permissions to actually edit this thing. There's a couple different routes you can take from here. You could download the shapefile to your machine, re-upload it to create a hosted feature layer. But instead of doing that, I'm just going to skip that and hit this button that says publish. So this is saying we've already got the shapefile in our workspace. We just need to use it for the source of a hosted feature layer on ArcGIS Online. So it inherits some information from the service you downloaded it from, which is nice, but you can modify this if you would like. Once you're happy with all that information, you can just go ahead and press save or share, whatever that button was in the bottom right. Are you with me so far? All right, any questions? So let's take a quick look at the data. Just opening it in Map Viewer. So we've got our state level data set. I use that fancy term enumeration unit. That just refers to when you're doing a Choropleth map where you're filling in areas with a color, or even with a graduated symbol map if the symbols are contained within polygons. The enumeration unit is the geographic area you are assigning attributes to. So in this case, we got Montana. One of the things that happens when you export data is the fields all reset their name. So we've got these abbreviations for all the different fields. We could return to the original feature service to figure out what they all mean. So I have another tab open here that's just the Living Atlas version of this. And if we go to the data tab there and click on fields, we've got actual descriptions of what all these fields are. And then we have their abbreviations provided as well. So one of the ones we might want to use is total population. That's P0010001. We go back to our map. What we could do is actually, if we wanted to rename a field, you can do that in Map Viewer using the Fields button on the right side when you've got your layer selected in the table of contents. And you can set the display name to total population. You can also turn on or off the thousands separator. Usually you'd want to have that on. All right, so we've got total population. If we scroll way down to the bottom, you will see that we have a couple of different area fields as well. We've got shape area, which is calculated automatically from the geography that is provided by the shapefile. And I think there's also some other area fields as well. If we just type in area to the search bar, we have area, land, area, water, and shape area to work with. So we've got the fields we need to make a population density map. This is going to look a little bit different in ArcGIS Desktop. You have a lab assignment that actually walks you through this. But it's also important to know how to do this in ArcGIS Online. So I actually need to back out of the map viewer. I'm going to hit the back button and go back to the information page for this hosted feature service. The data tab is where you're going to do any calculations that involve these various fields that are provided in your data table. So you've got the table view and you've got the fields view. Table view looks a lot like a spreadsheet, right? We can scroll through this, see what the different columns are, etc. Fields view just provides us a list of all of the column names or all the fields in your data set. Notice that the field names and the display names are all the same. So we might want to go into P0010001 and actually change that name to be more intuitive. Sorry, just total population. And close out of that. And now we actually see that name as being the display name for this particular field. So if we want to calculate a new field with population density, we don't actually have any blank fields available to us. So what you'd want to do is click this button in the top left that says add. And let's call it population_density. Just going to abbreviate that a little bit, pop dense. Notice that in the actual field names, you can't have spaces, you can't have special characters. It'll give you a warning if you do that, or it should. Yeah, so must begin with a letter and can only contain letters, numbers, and underscores. So if I tried to put a space in here, it would get mad. That's why we have the display names, right? If you want to make something more readable, you can put something with a space and density in the display name field. We've talked a little bit in this course about data types. Anyone want to guess or make an informed decision about what structure we want for these data? Yeah. Could be integer. That actually might be quite intuitive because, you know, people can't be divided into fractions. But I think for the purposes of calculation, the double is the best choice here. It's going to give you a decimal. And then if you wanted to, you could say, hey, round to the nearest whole number. Because the math operation in this case just requires that double format. So double is the same thing as a float value. The number with a decimal place. Integer is a number without a decimal place. A string is text, and then a date is a date format, right? Referring to a calendar date and time. So we're going to choose double, and we're just going to add a new field. So now in your table, if you scroll all the way to the right side, you can see your field that you just created. Let's also go and find that area field. And I want to go back to the original feature service to figure out what the units are for that area field. So notice that we've got area of land in square meters, which is not exactly what we want, right? So we've got to do some unit conversions. Let's use Google and say square meters to square miles. What would that conversion be? 1 square meters equals 3.861 e negative 7 square miles. So we divide the area by, we either multiply it by this number or divide it by that number right there. So I'm just going to copy that. And as you might expect, we're gonna need to add a new field, area. Let's call it area 2, an area in square miles. We are again going to want to double here because we're going to want a number with decimal places, and we're going to add that new field. Okay, now let's do some calculations. If you click on the header for the column in the data table view, you get options here. You can do sorting, like you can order the rows by the numerical value or the alphabetical order, or you can hit this button that says calculate. It's going to give you two choices. One is called arcade, which based on my experience is kind of most similar to kind of JavaScript calculations. Then there's structured query language, which is a little bit easier to understand for just simple mathematical operations. We're going to choose SQL here, or SQL. And it's going to give us this kind of intimidating looking screen. It has a list of all of our fields. It has some pre-provided functions here. Like some geometrical functions you might actually recognize. There are more available outside of this list as well. And then we've got our mathematical functions up top. So for any simple derived index, a SQL calculation will get the job done. So for area 2, we want to convert our area a land. We would double click that field. And it's going to recognize, because we're trying to store these data as a float value, that it's going to need to convert these to float before we can do the math. And then we're just going to hit multiply, which is the asterisk. And I believe that notation should work. Pasting in our conversion factor here. It must be a syntax error. So let's move that decimal place over by 7. Just get rid of this because I think it's probably confusing. So 0.000000, whatever. Click the checkbox to verify. And we're getting some kind of syntax error, which is unfortunate. Oh, I think it's because I clicked it twice. So just click it once. So when you write a expression that will go through properly, if you hit this checkbox, it'll tell you that the expression was verified. And we can hit calculate. And it should, if we're lucky, do that calculation properly. And now we can see some numbers that kind of make intuitive sense. Right, Hawaii being 6,000 square miles rather than, I think that sounds right, yeah. Hope I didn't get a 0 wrong. But instead of like 16 billion square meters. Even if that's wrong, let's just go with it. Someone look that up, what the area is of Hawaii. I want to see if I got that right. That's the general approach though, right? The approach is what matters. So we've got area in square miles. Now we can and we have population in one field. So now we can run a second calculation. Clicking on our population density blank field, calculate, SQL again. We're just going to choose P001, 0001. We're going to hit the divide button there, that /. We're going to find our field we just calculated, area 2. We're going to verify the expression. It is verified. And it'll run that calculation for you. Seems like pretty intuitive numbers, right? 44 people per square mile in Oregon. Montana, about 7. Did someone look up Hawaii? Interesting. I wonder why it was off by a few thousand. I mean, it could be that the islands were generalized in that case. Islands are really hard to get a detailed layer for. So, you know, depending on how generalized the islands were, it could really affect that area calculation. But thanks for looking that up. All right, so we've got our field. We ran some simple calculations. We've got population density. Now we can go back to Map Viewer. And because we have that derived index, we can symbolize using it. So we can edit our layer style in this case. Choose our attribute field that we just calculated. Population density. And if you look, right, we've got an outlier in the data set that is really drowning out almost the entire West. So this is where the data distribution comes into play. This is what we'll talk about next time. We can drag our color scale to see how it changes the picture. What we might also want to do is something called classification. We're going to talk a lot more about this. It improves our visualization. If we turn on the classification, I bet if we choose quantile, it'll be a really nice view of the population density. Quantile takes an equal number of states and puts them in the different classes. So if you have 4 classes, that means you're going to have, like, let's go to 5 classes to make my mental math easier. 50 states, 5 classes, there's 10 states in each class. That's the definition of quantile. And it shows the trends in population density a little bit better. All right, so that's how we do these calculations and use them for making maps.